నమస్కారం. డాక్టర్ బిఆర్ అంబేద్కర్ సార్వత్రిక విశ్వవిద్యాలయం విద్యార్థులకు స్వాగతం. ఈ ప్రసారంలో
we discuss now about the description of metamorphic rocks. The term itself is indicating metamorphic. Meta means change, morphic means form. There will be a change in the form of previous rocks like the igneous and sedimentary. The igneous and sedimentary rocks will change their form into some other form, and which we call it as a metamorphic rock. A metamorphic rock is of two kinds based on its genesis or source. If a rock is derived from igneous rock, we call it as orthometamorphic rock. If it is from a sedimentary rock, we call it as a parametamorphic rock. As we understand that rock is an assemblage of minerals. Minerals, two or more than two minerals make up a rock. A metamorphic rock like igneous and sedimentary will have its own type of assemblage of minerals, and these minerals will be at stability at equilibrium under given temperature pressure conditions. When in the earth sometimes there will be a change in temperature, in pressure and the circulating chemically active fluids. This change in the temperature, pressure and chemically active fluids will distort the equilibrium among the mineral assemblage. Thereby what happens is, in order to regain equilibrium amongst the minerals, that means to get stability, the process called as recrystallization takes place, and this recrystallization takes place either partially or completely. The partial or complete recrystallization of the minerals under solid state itself or semi-solid state itself will give rise to a rock known as metamorphic rock. So what we have to get in is agents like temperature, pressure and chemically active fluids will alter or change or modify the igneous rocks and sediment rocks into some other rocks called as metamorphic rocks. The metamorphic rocks are primarily due to these three agents only. When we think of the three agents, the first one is the temperature. The temperature, as we know well, thermal gradient. If we go deep into the earth, we understand, we know that the temperature goes on increasing with depth. So this is how the temperature is getting when we go into the earth. The metamorphic place or the metamorphic process takes place beneath the zone of weathering and zone of cementation. At certain depths only the metamorphic process takes place. By means of increasing temperatures at depths, they will be influenced, the minerals will be influenced, and they get alteration, recrystallization and formation of new structures, and thus will result in. The second agent is pressure. Pressure is because of overburden. The overburden makes or exerts pressure over the underlying rock formations. The pressure, as we know, is of two kinds. One is uniform pressure. The pressure acts uniformly on the entire place, and this uniform pressure will change or will bring a change in the volume. Generally or obviously the volume will be decreased. The volume of pre-existing rocks or previous rocks will get reduced on the influence of this volume. So there will be only a volume change by means of hydrostatic pressure. The second pressure is called directed pressure, non-uniform pressure or shearing stress. This directed pressure can act only on solids, whereas uniform pressure can act both on solids and liquids as well. Because of the directed pressures sharing stress or non-uniform pressure, there will be a change in the shape of the previous minerals. So, this way the pressure is of two kinds, one is directed pressure and the other one is uniform pressure. And the third agent is chemically active fluids. And we know beneath the earth we can expect a lot of circulating solutions, the meteoric waters, the juvenile waters. The meteoric, the juvenile waters are added with gases like boron, hydrochloric acid, etc. within the earth. And these solutions, primarily water, which are chemically activated with the dissolution of gases, will act or will transform in the process of change of igneous and sedimentary into metamorphic rocks. Amongst all the three agents, we can expect the role of chemically active fluids in the transformation of any rock. That means directly any temperature agent or pressure agent doesn't change a rock into metamorphic rock. It will be aided or it will be helped by the chemically active fluids. So, the chemically active fluids will help with the temperature, with the pressure, with directed pressure and uniform pressure, and change the rock into different kinds. So, after knowing about the role of different agents of metamorphism, we have to understand the kinds of metamorphism. The kinds of metamorphisms or the varieties of metamorphisms. Metamorphisms are broadly in the initial stage are classified into two kinds. One is the catamorphic zone or zone and grade and phases classification. As per the previous studies or the primitive studies, the entire span of metamorphic period or entire span of metamorphic zone can be classified into two. One is catamorphic zone and the other one is anamorphic zone. The catamorphic zone pertains to the upper portion, whereas the anamorphic zone pertains to the lower portion. In the upper portion, the temperatures are less compared to the bottom portions, and similarly or obviously the intensity of metamorphism is less in catamorphic zone, whereas in the bottom one or anamorphic zone the temperatures are high and the pressures are high. The pressure also varies. The pressure goes on increasing, directed pressure goes on increasing up to certain depth. After certain depth, the uniform pressure ceases to operate. So, at certain depth, the directed pressure will ceases to operate and therein only uniform pressure will apply. So, on the top portions or middle portions of the earth, the directed pressure goes on increasing. After reaching certain depth, at intermediate depths, the directed pressure will ceases to operate because the rocks at certain depths will have the property of plasticity. Because of this plasticity property, directed pressure cannot exist and the role of uniform pressure will initiate there. Then after the passage of some time, quite contrary to this previous classification, Grubenman, a petrologist, particularly studied about metamorphic studies, have classified the metamorphic rocks into three zones. They are epizone, mesozone and catazone. Quite different to the previous one. Epizone represents the upper portion, the mesozone represents the second or intermediate one, and the lower one is the catazone. In the three zones, the intensity or grade of metamorphism will also increase as well. At the top or epizone, the intensity of metamorphism is less. At the intermediate portion, it is intermediate in degree or intensity, and at the deeper portions, it is very high. So, after this Grubenman's study, a scientist by name Escola, he suggested some other classification which is called phases concept. The concept itself is called as phases concept, which is in accordance with the grades of metamorphism. So, based on the intensity of metamorphism, we can classify into low grade, medium grade, high grade metamorphisms. In the same way, Escola has classified the facies, low grade facies, medium grade facies and high grade facies. The facies concept was widely accepted by many petrologists. Facies can be said as a group of rocks having diversified chemical composition. Remember, the rock group having diversified or varied chemical composition, but they are having a similar type of mineral assemblage, and which were arrived at equilibrium under given temperature pressure conditions, and this is simply called as a facies. Again we discuss, we say that metamorphic facies can be said as a group or cluster of rocks having varied chemical composition but with a definite set of mineral assemblage which are aided or which are having arrived at equilibrium under given temperature pressure conditions. Based on this facies concept, petrologists have identified the sequential formation of minerals as per the grade, starting from the lower grade up to high grade. Minerals like chlorite, talc, biotite, etc. will crystallize or will recrystallize in the initial stage, and such minerals belongs to low grade facies. If a rock consists of or made up of chlorite, biotite, talc, etc., simply we can infer that such rock belongs to a low grade facies. And following the sequential arrangement of minerals in accordance to their intensity of metamorphism, the second one is garnet and the third one is staurolite. If any metamorphic rock is made up of minerals such as garnet and staurolite, we can say that that rock belongs to medium grade metamorphic facies. And in the following manner, if a rock is made up of kyanite and sillimanite, kyanite we know very well, it is having bladed property. The bladed propertied kyanite and the radiated needle propertied sillimanite, if they present in a metamorphic rock, we can say that that belongs to a high grade metamorphic rock. So all these minerals starting from chlorite up to sillimanite, we can call them as index minerals, as the index minerals are the reference points to know the grade of metamorphic rock. So after knowing about the facies concept and grades of metamorphism, we can discuss about the types of metamorphism. Metamorphisms are classified into different kinds based on the involvement of dominant agent. So as we already discussed, there are three agents only: the temperature, pressure and chemically active fluids. And we know that pressure is of two kinds: directed pressure and uniform pressure. So starting with temperature or heat. If a process of metamorphism happens because of temperature or because of heat, we call all such transformations as thermal metamorphisms, and the metamorphic rock as thermal metamorphic rock. In the same way, sometimes what happens is magma will intrude into the country rock. If rock fluid at high temperatures into the country rock, it intrudes, what happens? Magmas are obviously at very high temperatures. The intruded rock wherein the magma has intruded will cause of very high temperature changes. Such type of metamorphic processes are called as pyrometamorphic process, and the process has pyrometamorphism. If because of this magmatic or emanations or intrusions, if the transformation takes place at lower temperatures comparatively to pyrometamorphism, we call it as contact metamorphism. So based on temperature, we can classify the metamorphic kinds into three: thermal metamorphism, pyrometamorphism and contact metamorphism. In this category itself, sometimes what happens is the intrusion of magma will causes some burning and fritting effects, and such type of modifications are called as caustic metamorphic categories. So, the second agent is the pressure. The pressure is of two kinds, directed pressure. Sometimes directed pressure alone with the help of little amount of chemical fluid will act on the pre-existing igneous and sedimentary rocks, and this influence of directed pressure on brittle and hard rocks. They act on brittle and hard rocks, they make them mechanically breaking down into different fragments. Here new structures will rarely form. If it is an argillaceous substance, it leads to the formation of cleavage, and such cleavage is called as slaty cleavage. The metamorphic process resulted by means of direct pressure alone is called as cataclastic metamorphism. Cataclastic metamorphism, and the rock may be said as cataclasite. This is the second kind of metamorphism based upon the agent. Sometimes directed pressure will be influenced or will be assisted with the help of chemically active fluids. If together chemically active fluids and directed pressure acts over the rocks, the result is disastrous. What happens is they make the melting points lower. The mineral's original melting points get lowered and the transformation takes place very intensely. Such kind of metamorphism leads to the formation of foliation and lineation. The property foliation and lineation will result, and the minerals will be oriented perpendicular to the directed pressure, and the resulting metamorphism is called as dynamo-thermal metamorphism. This metamorphism is called dynamo-thermal metamorphism. This is a very important metamorphism wherein all types of schistose rocks and gneiss rocks will generate. Remember, schists and gneiss will be resulted due to dynamo-thermal metamorphism. Then the third one or the fourth one is called as uniform pressure. Sometimes uniform pressure with the help of chemically active fluids will act on the pre-existing rocks, and this will bring in a change in granularity. Granular property will be assigned to the pre-existing rock. The resulting structure is called as granulose structure, and granulose structure will be resulted due to influence of uniform pressure, and such type of metamorphism is called as plutonic metamorphism. So these are the kinds of metamorphisms based on the agent which involved in the metamorphic process. We have to understand the individual kinds of metamorphic rocks. A metamorphic rock, important one is, this is called as slate. This rock is known as slate, and we know among the metamorphic rocks, the important one or the low grade metamorphic rock is slate. We know a sediment rock by name shale. A rock by name shale on dynamic metamorphism or cataclastic metamorphism will give rise to slate. All argillaceous rocks where their grain size is very fine on metamorphism will result into slate. Sometimes the shale will also transform into hornfels. This is a rock known as chlorite schist, and as we discussed, schistose rocks are having given their name because of their structure is schistose. Here all the tabular flaky minerals, the tabular flaky minerals will align parallel to one another and will resemble like the complex of micaceous minerals. The complex of micaceous minerals will be like this. The minerals will be oriented parallel to one another and brings in a structure called as schistose structure. All schists based on the dominant mineral will be called as their prefixes. Say if it is, this is chlorite schist. As this schist is having chlorite as a dominant mineral, we call it as chlorite schist. If it is having a dominant mineral quartz, we will be calling it as quartz schist. If it is having biotite, we call it as biotite schist. The same way, this is a gneissic rock. You see the banded property here. We see banded nature in gneissic rock. We see alternative bands. One is a schistose layer followed by granular property. Schistose, granular. Alternatively, the presence of schistose, granular, this property is called as gneissic property, and the rock is known as gneissic rock. Here, this is called as granite gneiss. As we did it in case of schists, here also based on the dominant rock from which it is derived, it will be named as a prefix. As this rock is derived from, this gneiss is derived from granite, we call it as granite gneiss. Like the granite or the parent rock, this gneissic rock will also have quartz and feldspar. Quartz, feldspar do dominantly present in this gneissic rock also, but their orientation will be different and their hardness will be different. This is a very important rock called as marble. This rock is known as marble. We see any limestone. This is a rock known from or metamorphosed or derived from a sedimentary rock known as limestone. Limestone on metamorphism will give rise to granular propertied rock known as marble. Plutonic metamorphism will make a limestone material into a marble rock, and this is called as marble. We see a lot of sand on accumulation will become a sandstone. A sandstone is a sedimentary rock, and this sandstone on metamorphism will get further compacted. The individual grains or the cohesion or compaction, lithification and diagenesis make the sandstone very hard in metamorphic rock, and we call this transformed sandstone into a metamorphic rock as quartzite. This also consists of quartz as a dominant mineral, but in a very compact nature compared to sandstone. And finally, this is amphibolite rock. Amphibolite rock. A amphibole or hornblende group of mineral, which is the dominant mineral in the amphibole family. If amphibole family minerals which dominantly present an igneous rock will transform into a metamorphic rock, the resulting rock we call as amphibolite, and this rock is called as amphibolite. And this is how we have to understand the different kinds of rocks, the various types of metamorphic rocks which are resulting either from igneous or from the sedimentary rocks.
మా కార్యక్రమాలపై మీ సూచనలు సలహాలు ఆహ్వానిస్తున్నాం. మీ సూచనలు సలహాలు మాకు తెలియజేయవలసిన చిరునామా: డైరెక్టర్, ఆడియో విజువల్ ప్రొడక్షన్ అండ్ రీసెర్చ్ సెంటర్, డాక్టర్ బిఆర్ అంబేద్కర్ ఓపెన్ యూనివర్సిటీ, ప్రొఫెసర్ జి రామరెడ్డి మార్గ్, రోడ్ నంబర్ 46, జూబ్లీ హిల్స్, హైదరాబాద్ 500033.